This is the video for the cat and mouse routines. Over on the left we have one routine, and over on the right we have another routine. We'll start with the one on the left. It sets the value of small to 1, divides it by 10,000. It sets return value to 25, divides it by 100. Then it sets the 25 values at matrix to 0. Well, we're dealing with a 5 by 5 matrix, which starts out at offset 0 in matrix, so it's zeroing out all 25 of its values. Then it sets A to the game number, sets B to 100, subtracts the game number from B, so then it divides A and B both by 100. At the beginning, A is 0, so when it divides it by 100, it's still 0. B, however, was the difference from 100, so it is 100 now. It divides it by 100, it becomes 1. Then it's going to go around the loop for I of 0 to I of 18. It's going to go around there 4 times. It's going to be 0, 6, 12, and then 18. 4 different rows. Each time it's going to set the value at matrix plus I to the value of A. Well, at the beginning we know A is 0. And we know that I here, being offset 6 each time, it's going to say, well, I first go to offset 0, but then I add 6 to the offset and it's here. It's putting all those values of 0 on the diagonal, but only for the first 4 rows. The value of B, which starts out at being 1, is going to be put at one position past there. Well, that would be this position here. There is a 1. But the next 3 are not 1s, and we'll see soon why that is. Once it's out of that loop and does those 4 rows, it sets at matrix at offset 24 a 1. That's the 5th row here, and there is the 1 at offset 24 of the 25 values. Then it has a jump here. We're not going to take that jump, so we won't consider it. Then it says for I of 5 to I of 17, 6 at a time, we're going to go to matrix plus 2I. Well, it starts out at 5, it's 7. It's going to go to this position. Now, it put a 1 there, but here it says, no, divide that 1 by 2. That's why here it's actually 0.5. Then it says that value that you put there, I also want you to put at offset I. Well, that was offset 5. That's this position. So it's putting a value on either side of the diagonal. Well, those values are for the probability of it going back 1 row, and the other is forward 1 row. Well, in this case, it's our mouse, the probability that our mouse is moving. So it does that for each of the 3 rows. It takes that value we made up here, divides it by 2, and puts it on either side. Each row is going to add up to 1. That's what this routine does. It builds these initial matrices. Over here is the initial matrix when the game number is 99. Again, we see that the rows add up to 1, and at offset position 24 there is a 1. The other matrices down here show for what happens if that matrix, this one, is raised to the 256 power. Well, this last row indicates that the cat has eaten the mouse. And we see after 256 iterations of this, it says the mouse has been eaten. However, over here with game 99, sets the probability of staying in a particular row at 0.99. See, all in the diagonal. And we see the difference being very small that the cat moves. Here 0.005 that he'll go back one row, and 0.005 he'll go down one row. So the chances of him being eaten is much less. So we see here when that matrix is moved to the 256 power, it's not a sure thing that the mouse has been eaten. There's still probabilities that the mouse is still wandering around these 4 rows. Now we're going to look at the other routine. First it sets A to 20, B to 110. These values are going to be used for the position on the screen where it's going to place the matrix. A is going to be used for X, and it's going to be offset in beginning 20 from the left side of the screen. B is going to be used for Y. It's initially going to be 110 down from the top of the screen. Next, it sets C to 0. Then it says for J of 1, and down here we have J, 3, 1. It's going to go around that loop 3 times. Next, it sets X to that value of A. Well, we had 20. Then it says for I of 1. And down here it says next I 3, 1 at a time. Now I'm going to show you what it's about to do. I'm going to look at the actual program. Here is the program. What it's saying there is it's going to put 3 across here 3 times. That's why it's going around 3 to do 1, 2, 3, and then it's going to change the row 1, 2, 3. Now I'll go back. So that's what these 2 outer loops are doing. They're changing that position. Then it says set LS to 5. That's the offset between rows, and we know there's 5 in a row, and that's all there is, so it offset 5. Then it says MS, which is the number of columns, to 5, NS to the number of rows, which is 5. Then it sets the value of Y to B. Well, up here's that value of Y. Starts out at 110. Then every third time it's increased by 110 down here. Then it says box N. That is, it's going to show the numbers in the matrix. And here it says the matrix is offset C. This 0 here indicates that the values aren't updatable. They don't have a click number, so we can't change them. And this value, the 123 or 123,000, indicates that this is something with rows and columns. You're not just going to print out one value. You're going to go back here and see how many columns it has, how many rows it has, and then print it all out. And as you could see, it prints out all 25 values. Then it sets NS to 1005. That indicates that this is a square matrix, 5 rows and 5 columns. That is going to be used by this multiply list, mul-L, to multiply this matrix by itself, matrix plus C times matrix plus C, to make matrix at 25 plus C, which means this matrix is squared, multiplied by itself, but the result is put offset 25 from it. It's at offset C, its result is at offset 25C. So every time it goes around here, it's going to increase C by 25. It's going to multiply the previous one by itself and put the answer 25 beyond that. So each time it goes around, it keeps increasing the power of the matrix, but putting it at the next position, as we see here, as it adds 25 to C each time. Also, because it's displaying it out, here is where it adds to X value of the position. That's the horizontal value, 335. Then it says for K of C. Well, it added 25 to C, so it's this matrix, the one it just created. If its value is greater than small, it goes down here to BE. Otherwise, it sets that value to 0. That's because there's so much accuracy in the arithmetic being done here that sometimes you have a number that's 0.10 zeros and a 1. That just makes it difficult to read the values that really are significant. So this is just to eliminate those very small values. Remember up here we told it what a small value was. Alright, when that's done, then it comes down here for the next K, 24 plus C to 1. So it's going to go around here for all the times to show all of them. And then next it adds the 3 to, well, adds 1 to I, checks it with 3. Then it changes the offset for Y to 110 plus, and then it goes around the other one 3 times. And again, we'll go and we'll look at it. It does these 3, then these 3, then these 3. Alright, that's the end of the video for the cat and mouse routines.